So far we looked at how we can use convolutional neural networks for any spatial data and specifically for image processing. But now we kind of want to sort of really explain the fact that convolutional neural networks are not specific to that one use case, but in fact they can be used for a variety of different tasks. And the main takeaway that we want you guys to have at the end of this is that these CNNs are essentially basic building blocks that you should be able to use for other tasks and basically parts of networks. It doesn't have to be the entire network. It can be either the beginning of the network or in the middle, whatever it is. But basically, we're going to talk about the advantages that it'll provide regardless of what your data set or what type of task it is that you're trying to do. So first, what we want to show is a very simple document classification task. And before we get into the actual data set, I want to go over how we would actually process, let's say, a sentence using a convolutional neural network. So very much like images, we still need some way of representing our text. So if you look at the image here, this book is awesome, period. What we want to do is first represent this, and how we're going to do this is, we can use something like one-hot encoding for each word, or maybe if you have embeddings, you can go ahead and use those. But regardless of that, you need to represent the sentence in some way. So now we're going to have this 2D input instead of 3D images like before. So now since we have this 2D input, our filters are also going to be 2D. And the filters are basically going to convolve across this representation that we have for our text. Now with the filters, the actual width has to match with the representation dimension of our text, but the height can vary. And the height can vary between 1 to whatever it is, and that basically is going to act as our sliding window as we convolve through the text. Now you see here we're using words. We don't actually have to stick with words. We can use something like characters, and that would give us a different set of advantages as we convolve through. And just to point a few of them out, using character representation, using convolutional networks with characters is going to help you with things like if you have misspellings or out of vocabulary inputs, things like that. A very brief example would be me saying I love this restaurant with all the words spelled correctly versus me saying I love this restaurant with a couple O's in the word love. They both express the same underlying sentiment or meaning, but they're spelled differently. So using a convolution for characters would sort of help with these types of tasks, because at the end of the day, they're both representing the same thing, even though they are different inputs. So those are things you can do. So let's quickly go through what the pipeline would look like. You feed in your 2D input, use your 2D filters, convolve through that, and you're going to get the outputs. So you can see here, for this input, using this where the window size is 4, basically 4 words, we're going to get 2 outputs here. And you can see for the other filters, we get all these outputs. Once we get the outputs from the convolution, we're going to apply max pooling again. Now with max pooling in the textual context, is like saying, I have all this information after convolving, I just want to take the most important, I want to take the most relevant information out. So you're just going to take one of the values from the convolution, and then we're going to concat all of these. So we're going to join them all together and then flatten them out, and now we're ready to feed into another fully connected layer. Again, like before, this is pretty much same as image recognition. It's going to help us classify whatever it is that we want to classify. So that's pretty much the quick visual primer for using CNNs for text. I just want to quickly talk about a few advantages before we get into coding this. With convolutional networks, Alf previously talked about this increased receptivity field that you get. Basically, your layers downstream get to see a large part of the input. Now, we saw why that was so useful for images, but that's actually just as useful for text as well. Quick example is, with text, the whole meaning could change with as simple as just one word not being there. Example is, I really like this versus I really don't like this. The only change is the word don't. And having this higher level of receptivity is going to let you see why this local change here is going to have such a big effect on our final classification. So just a few advantages from convolution, and like with image recognition, we have you can compute everything very quickly. You can parallelize a lot of the aspects with the text model here. So now let's go ahead and code, the very simple document classification we talked about, all of this code is provided as a separate folder. It's called CNN_NLP. We're just going to talk about some of the important aspects inside the code because it's very similar to a lot of the components we've already seen. So we'll go through basically the data, the model, and then sort of how we're going to train this. So talk about the forward pass, things like that. And then I'll show you, using one of our trained models, what the inference looks like. So first, the big thing that we want to focus on is how we're going to represent the data. I told you before we need to represent our text, so it's going to be a 2D representation. But unlike images, where let's say in an image data set, all the images are of the same dimensions. But with text, we can have sentences of all different sizes. So we don't want to use those. We can't use those filters just on a batch of sentences of different sizes. So this is where padding is going to come in. We're just going to pad with zeros, and basically this is going to allow us to use those filters on a batch of sentences at once. So that's the only difference here in terms of the actual data representation. And then we have the padding function here. And then with the actual model itself, I talked about before how the height represents the sliding window that we want to use. And we want to be able to use different sliding windows. And if you use something like text or character representation, using different sized windows is just like capturing different sized n-grams. So if I use a kernel size 3 filter, that's like capturing trigrams or something like that. So that's going to be pretty cool. So we're going to go ahead and actually use something called this conv here, where I just specify the number of input channels, and then in the kernel size, you can see here I'm using 2. That means I'm trying to capture the bigrams. We're using character level convolution here. So we, in the actual code, I think I use size 2, size 3, and size 4. So we get to capture a nice variety of different grams, and then we're going to use that to classify what type of document it is. So that's the code here, and we do a lot of the same steps as our previous lesson, properly initializing the weights. Now the forward pass is just passing our input through all the convolutional layers. We have several different convolutional layers to have that increased receptivity field, and then now we're going to get our outputs to say what class it's in. So let's go ahead and run this brief example. We already have this model trained. You can go ahead and tune it further if you want, but this gives pretty decent performance, around 87% for document classification. So I have this sample sentence. I wanted to know what type of document it is. So the sentence is, with the increase in sensor capabilities, there's been a surge in using them for bioinformatics. So this is sort of a science/technology type of document. And if we run this example, we get to see, so the prediction is it's saying 71% chance that it's a science technology article out of these 4 possible classes. So, hope you saw the use of using CNNs with text classification. Again, the takeaway is CNNs are not just for images. We can use them for a variety of different tasks because they carry those advantages across all different types of tasks that you may have.